everyone, this video today is a continuation to chapter 8 and we are going to be looking at chapter 8.2 area of sector. The objectives of today's lesson is to find the area of the sector of a circle by expressing the area of a sector as a fraction of the area of the circle. Next, we will also be looking at finding the area of a segment of a circle. You would have recalled from the previous lesson the different terms that we have covered about a circle. For example, a chord, an arc, a sector, as well as a segment. Before coming to this video, you should have covered the previous video in our SLS lesson. In that video, you would have learned how did we go about deriving this formula for finding the area of a sector. You would have known that to find the area of a sector, it is actually proportional to the area of a circle. So in this video, we will be covering some practice questions that make use of the area of sector formula. So let us first take a look at practice noun 4 found from your textbook in page 258. We are given this figure over here where O is the center of a circle of radius 15 cm. It is also given that the length of the minor arc is 33 cm. So the minor arc is this part over here, and that is 33 cm. In part I, we are required to show that angle AOB is approximately 126.1 degrees. And when we state that it is angle AOB, we are always referring to the smaller angle, either acute or obtuse, okay, which is over here, rather than the reflex angle. So to prove that, okay, we will make use of this, the length of arc given, right, which is 33. So we form an equation found as stated over here. After forming the equation, we will do some manipulation and we will arrive at saying that we will get 126.05 for truncated 5SF and finally 126.1 degree, which is what we are required to show. And in part 2, we want to hence find the area of the major sector OAPB. So the major sector would be referring to this area over here. What we can do is to find out what is the angle, the reflex angle AOB, which would be 360 degrees minus away 126.05, which I have done here. Then after that, I divide it by 360 and multiply by pi r square, where r is actually 15 cm as given in the question. So finally, my answer would be 459 when rounded to 3 significant figures. Next, we will take a look at exercise 8b, question 7, part I. We are given this figure over here and we want to find the perimeter and the area of the shaded region ABCD, where we are given that r is equals to 10, big R is 20 and m is equals to 45. Okay, so let us first find out what is the area. To find the area, there are actually 4 different parts that we have to look for. First of all, we need to find the arc length of AB. Then we need to find the arc length of CD, as well as knowing the length of the sides AD and BC, which are equivalent to each other. So let us first find arc length of AB. Arc length of AB is actually a part of the sector OAB. So we will consider m degrees, which is 45, over 360 times the circumference of a full circle where the radius is actually 10. So that's why we will substitute 10 over here. We will do the same thing to find out the arc length of CD, but the difference is that the radius is actually larger at 20 cm. After doing so, we will then compute the value for AD and BC, which is going to be the difference of big R minus away small r. That's why we take 20 minus 10 and we see that it is equals to 10. Hence, we can conclude that the perimeter would be 43.6 cm. Let us now take a look at finding the the area that we want. So in order to determine the area, we need to find the area of the larger sector and then taking the difference and minus off the smaller sector OAB. So when we first find the sector area of AOB, we will take 45 degrees over 360 times pi r square, where the radius is 10. Okay, then to find the sector area for COD, which is the larger one, the radius that we take will be 20. So after finding the areas that we have already, we will take the difference and we will get the shaded area to be 118 cm squared, rounded to 3 significant figures. And now moving on to exercise 8b, question 8, we are going to be looking at this figure over here, and we are told that the area of the shaded sector is actually 5/18 of the area of the whole circle. So although we are not given any information about the area, neither are we given any information about the angles, yet we are supposed to find out what is angle POQ. So how do we go about doing that? We need to keep in mind that the formula for finding the shaded sector, or rather the formula for finding the area of a sector, is actually proportionate to the area of the whole circle. So if this area that is shaded is 5/18 of the entire circle occupies 360 degrees. That means that the sector itself will also occupy 5/18 of the entire circle. So therefore, we can just do a simple calculation of 5/18 times 360 degrees, and we will get the answer 100 degrees. Now in part 2, we are given that the area of the shaded sector is 385 cm squared, and we are required to find out what is the diameter of the circle. So since we already know what is the angle, which is 100 degrees, we can form an equation using the area of sector formula and equate it to 385 as given in the question. Following from there, we will do some manipulation and arrive at r squared to be about 34.041. We subsequently take the square root and we have this value. Take note that we are trying to find the diameter, and 5.8345 is only the radius. So therefore, we need to multiply by 2 in order to get our answer to be 11.7 cm when rounded to 3 significant figures. Moving on to practice now 5, we are given that this figure ABCD is a trapezium in which AB is parallel to DC. So we got these two as parallel lines. Next, we are told that AB is 19 meters, DC is 15 meters, and angle ABC and DCB is 90 degrees. So PXB is an arc of a circle, center A, and PYC is an arc of a circle, center D. So with this information about PXB and also PYC being arcs of a circle, okay, we will know that if this is the center and this is 19 meters, AP will actually be 19 meters over here. Likewise, if D is the center of this sector and CD is actually 15 meters, which is the radius, this means that PD is actually 15 meters. So now that we understand this, in part I, we want to show that angle ADC is approximately 96.8 degrees. So angle ADC is actually this entire angle here, right, that I'm coloring in green. Okay, so now that we see that we have angle ADC in this way, how should we go about finding this angle? It is not very easy to find this. It is not going to be easy to determine this angle because we are not given any information about the area of the sector, neither are we told about the arc length. So what we should do is to perhaps, create a right angle triangle in this manner and try to find out what is this angle here. Because after all, from this horizontal line to the line CD, it will be 90 degrees. So the angle that we are trying to find will be 90 degrees plus this small angle that we are going to find. I have created out another triangle as shown here. So this is the angle that we will try to find first. Okay, so if I were to label this as M, this section here as M, AM will actually be 4 meters because that is taking 19 meters minus away 15 meters. Next, AD is 34 meters because as explained earlier, we have AP to be 19 and PD to be 15. This is shown in the working here. So because we understand that this is going to be a right angle triangle, we can use our Tuakaso, where we will consider sine, which is opposite over hypotenuse, to actually find out the angle of ADM. So we see that the angle of ADM will be about 6.7563. Don't forget that we are trying to find out angle ADC, so we need to actually add up 90 degrees, and finally we will be able to show that angle ADC is approximately 96.8 degrees. Hence, we have shown this. Next, we take a look at the last part, which is to find the area of the shaded region. To find the area of the shaded region, we need to consider to find the area of the entire trapezium. Then we minus away the area of this sector here, and also to minus away the area of the other sector. So in order to do this, we need to find the respective areas. To first find out what is the area of this sector on the left, we need to know what is the angle of BAP. To find out what is the angle of BAP, or rather BAD, whichever that you want to name it because they refer to the same angle, we can realize that AB and CD are actually parallel to each other. Because they are parallel to each other, there will be interior angles being formed over here. Hence, what I did was to take 180 degrees minus away the angle that we found for CDP, which is 96.756 degrees. So I got 83.244 degrees for angle BAP. Then I can proceed to using the formula for finding area of sector with the radius being 19 and get the answer 262.24 meters squared. Alternatively, to find out what is the angle of BAD, you could use the triangle that we formed just now, where I had the point M here, A and D over here. We recognized earlier that this is a 90 degrees, and we previously already found out what is this angle here, so as to help us to find angle CDP. So we can use angle sum of triangle to then subsequently find out what is angle MAD, which actually refers to the same angle as BAP. Moving on to find out what is the area of sector CDP, we will use the angle that we have already found in part I and use the formula with radius being 15 and get the answer to be 189.97 meters squared. So the only thing that we need to find next is to find out what is the area of trapezium before putting all these pieces together. To find the area of trapezium, we understand the formula for it would be to take half times sum of parallel sides times the height. So the sum of parallel sides is actually 19 meters and 15 meters. But what about the height BC? How do we go about finding the height BC? We need to recognize that BC is actually the same length as MD, as per the triangle that we found earlier, or rather the triangle that we used earlier. So we earlier said that AM is actually 4 meters. And we see that AD is actually going to be 19 plus 15, which is 34 meters. Since this is a right angle triangle, we can use Pythagoras Theorem to actually find out what is the value of MD. Yes. So MD is actually the same as BC. Okay, so therefore we get 33.763 meters. Then piecing all this up, we will get the area of trapezium to be 573.971. Following from there, I decided to take the area of trapezium minus away the area of the two sectors, and I will get 122 meters square when rounded to be 3 significant figures. We have come to the end of today's lesson. Please complete the following questions on foolscap paper found in your textbook exercise 8B, question 9, 10 and 12. Please complete and submit the assignment by Wednesday 24th of June. I hope that you will have a great day ahead. Goodbye everyone.